Hey, what's up? It's Mark at Alchemist.camp, where we learn Elixir and Phoenix by building things. Today we're going to do some load testing, and first I'm going to show you what the performance of various types of pages on the site that I run is, and then after that I'll show you two really simple things you can do to improve Phoenix performance by a good amount right out of the box. Then we'll run the tests again, and you can see the difference. This site, loader.io, is a service that will send lots of traffic at your site so that you can test how well it withstands lots of traffic other than by getting a post to the top of a subreddit or Hacker News or something and then having your site crash at the worst possible time. They do obviously require that you verify that it is your site. The way that works is they give you a long file name. You've got to put a file with that name on your system. And the way I did that is I just added an exemption for this file name in my, or not an exemption, but I just added this file name, which you can't see because it scrolls way over, to my plug.static. And then I copied the file that they gave me into the static assets directory. And that was that. I've tested it on 3 different kinds of pages on my site. The simplest is the home page, and I'll show that to you. So there is a big image, but other than that, there's not too much going on. And that page does okay with 500 requests per second. So you can see this is how it went. It looks like it was a little bit harder ramping up at the beginning. And we had a load of over 600 a second. That's because it does take some time to process them. On average, though, it was only about 1/3 of a second response time, and that's obviously the time it takes their server to get a response. So that's very snappy, and 500 per second is not bad. By the way, this is on a $5 a month DigitalOcean droplet, so this truly is a good level of performance for such a weak server. I tried it at 750 requests a second, and it did survive it. Still reasonably fast response times, just over a second, but the error rate was over 12%, and that means a good number of, if this were like a real situation, that would mean a lot of people would be going from whatever link to your site and seeing timeouts, and obviously you don't want that. And if this did actually happen, a good portion of them would hit reload, which would actually just send even more requests per second to your site, and it would probably crash. So the limit is somewhere between 500 and 750 requests a second. Next is the episodes page, and this page has a lot of stuff on it. It basically gets every single episode of this very screencast or this very channel that you're watching right now, and it finds out what tags are associated with it. It gets the links to the YouTube channel. It checks to see if they're restricted to premium or not. And as you can see, I have a lot, and I'm putting them all on the page. That's mostly just for user convenience. I don't want to make people do too much pagination. I'll probably limit it at 100 per page, but it's a much more difficult task than just loading up this simple page. On the episodes page with 200 requests per second, no errors, but it gets kind of slow. It's like 7.5-second response times. My guess is that's because we're just demanding a lot of the database. All right, I also tried it at 250 requests a second, and that just was a complete failure. The test didn't even finish because there were so many errors. The third kind of page that I tested is a page for a single episode. This is loaded from YouTube, so obviously that's no burden on my server, but there is a fair amount of stuff linked. There is some logic, like the source code will only show up for someone who's logged in and who is a premium member, and something else shows up if they're not. And loading in this. So it's a heavier weight page, but it's still just one page. So it's doing more logic, more database joins on a single episode, but we're not getting every single episode out of the database. And its performance came out even worse, actually. So at 150 requests a second, it was pretty slow and getting some errors. Then at 200 requests a second, it was even slower and so many errors that the test aborted. Okay, so that's the current status. I'm sure what you're really wondering is, how do we make stuff faster? Looking at our DigitalOcean dashboards, this machine is barely working at all. And you can see there, there's some little spikes, but not that much. So let's have a look at our config. First thing we can change is the logging level. By default, it's set to info, which means we're writing each request to log twice. And we're also logging a bunch of things that we don't really need to be logging in production. And on top of that, in my own personal setup, I'm doing event tracking with Keen.io, which means every single request, I'm spinning off another task and getting the headers, and if the user's logged in, I get that and get the date and do some geolocation and send all of this data up to Keen.io. And looks like I was not properly excluding localhost there. So I'm going to change this to warn, which will still log the most important things, but it's a much more performant setting to have in production. The second change is a bit more interesting. Second change is related to concurrency. By default, the Cowboy web server has this option that's called max keep alive that's set to 100. That means each connection can handle 100 requests. And that means if you've got a lot of requests coming in and from people that are hitting more than one page, you're not going to reuse the connections. You'll handle 100 requests and then you'll have to shut down the connection and then make another connection, and that will affect performance. You set it ridiculously high, there may be some other trade-offs, but we're going to increase that. Let's see, it's inside protocol options. So protocol options, max keep alive. I'm going to set this to 50,000. So that means each connection can handle 50,000 requests. Save that. And these are the only two changes we'll make for now. So got to commit that to our source control. So git add dot, say increases max keep alive and logging level. All right. That was a typo. We wanted git commit, not git add. All right, and now I'm just going to use edeliver to build another release. All right, it's built, so now we need to deliver it to production. Makes edeliver deploy release to production. So you can see I have these in my history. That's because I have a workflow where, let's see, just a sec, gotta choose the current version of the app, which is 0.1.5. So we deliver the release that we just generated. If I chose a different one, it would deliver the release from that version of my app. Yeah, I typically have one tab open where I do all of my committing, building of releases, and delivering of them. This will take a moment because we've got to upload the whole repo, and then it'll be built on the production server. Okay, it's deployed to production, so now we'll just restart the server. And then we can see how much of a difference it makes having the max keep alive set to 50,000 instead of just 100. So let's actually rerun the test that we just did for each of these scenarios that failed. So single episode page, it did not fare well at 200 clients per second. That errored out, so let's just rerun this exact same test. And now it's still getting some errors. Far fewer errors, and the test is progressing, but that does not actually look very good. Let's see here. Yeah, so that's a very modest improvement. Let's go back to 150 clients per second. How that one went. That one also had a 13.4% error rate. We'll run this now. Got 300 clients per second active, which is because it takes longer to finish processing one than it does to add the next one. But all in all, it looks like it held up pretty well this time. Instead of a 13% error rate, it was 0.4, and we did get through them all. So I would say now it's a realistic 150 requests per second that we can handle on the single episodes page. Now the listing of all the episodes, I don't expect to improve so much. So add 7489 was our average response time, no errors. We'll try that again. The reason I expect less improvement here is because we're still pulling every single episode out of the database and doing joins on them. So it's still pretty slow. And it looks like, yeah, we're gonna end up with pretty much an equivalent run as we had last time. All right, and then the home page, I believe this is where we'll see a bigger improvement. So for 500 requests a second, there was no problem. All right, so let's not even bother looking at that one. For 750 requests a second, we had a 12% error rate and still pretty snappy response. And we see a much lower error rate, and it looks like things got a little bit better as the test went on, which is kind of interesting. Okay, yeah, and we're getting a much faster response rate as well, which makes sense because this one is it's doing a little bit with the database, but it's nothing crazy like the other two were. So this was much more successful. Let's actually up this to, you know, let's go for 1200 requests per second. This is going to be pretty brutal, but it just might get through the test without airing out. We're seeing the response times go up, which is not a good sign. The error rate is still lower than it was when we just had 750 requests a second before, though. So this is a pretty massive improvement. So we processed 14,000 requests, was average response time of 1175 milliseconds, 12.7% error rate. So that was 1200 requests a second. And in comparison, previously when we tested 750 before making the changes to the server, it was actually responding more slowly, same error rate, and handling far fewer total requests. So that's a pretty big win. Fortunately, the episodes didn't really improve at all, and single episode page at 150 requests a second did improve considerably. Before, 150 requests a second wasn't really doable, and now it's kind of on the cusp. Less than 1% error rate is probably not going to get out of control. Decided to try this again with an intermediate setting for max keep alive. Now I'm going to try allowing 10,000 requests to be handled by each connection. So we'll try a single episode page again here. And this is 200 requests a second. It is still slow. Not seeing error, well, seeing barely any errors. This may be improvement. We have before. Oh, before it was aborted due to errors. And this time, only 1.1% errors, and it finished. Okay, so we've probably gotten the low-hanging fruit from changing that one setting. And on the whole, it was a massive win for speeding up the homepage, like almost doubled. The performance of this final test was between what we had for 500 and 750 before. And also a great improvement on single episodes, went from 150 to 200 requests a second. Not as much on the full episodes page. And I think the next place to improve this, like if the site had anywhere near enough traffic that I needed to be worrying about handling more than 200 requests per second, I would actually store all of the episodes in ETS, because that would hold them in memory. Then the only time we'd have to hit the database for them would be, say, if I published a new episode, or if the server had been rebooted and the first user was making the request and it wasn't loaded into ETS yet. Can't say for sure, but I think that would probably get all of the pages in the same realm as the homepage in terms of how much load they could handle. And that is not bad for a $5 a month DigitalOcean droplet. We've seen there's some pretty simple tweaks we can make to get a lot more performance, and honestly, for most sites, even if it's ad supported, you need more than 200 requests per second. You can probably afford to go up to the $10 droplet or the $15 one. See you next time.